All right, welcome everyone. Today is Wednesday, the 15th of November, 2023, and this is the Cluster API Karpenter Feature Group meeting. This meeting is a sub-project of SIG Cluster Lifecycle. So as such, we follow the Kubernetes SIG's guidelines, which basically means please treat everyone as you would expect to be treated, or explicitly, please be kind to each other. And if you'd like to talk, please raise your hand and I'll call on you. So we had a meeting before just to kind of talk about this and get things kicked off, but I guess this is the first, real kind of regular meeting that we're going to start having here. And I've proposed an agenda topic that I'd like to talk about, which is basically, is it feasible to build a pure CAPI provider for Karpenter? And I've been studying the code for a while now and trying to figure this out. And I've always optimistically thought it is possible, but I wanted to talk about it here and kind of get other people's thoughts on this. And is this even the direction that we want to go as a community? I don't know. Does anybody have thoughts, or would anyone like to talk to this? What does everybody here want to do? Do people want to see individual, providers being created? Would it be useful to have us, if we can make a generic cluster API provider, is that the path we want to go as a community?
Have you cracked open the Karpenter Cloud Provider API? Like, I think that's kind of the crux of the whole question of
Yeah.
it's where the implementation starts.
Now,
Maybe
are we
not.
talking about the node claim part or just the interface for the cloud provider?
There's kind of two extension points in Karpenter. There's the Karpenter Cloud Provider Go interface, and then there's the node class provider. And the node class is a CRD that's almost just like a do whatever you want thing. So we use it for like AWS tags, subnets and security groups, et cetera. Essentially anything that's not modeled by Kubernetes, but is API surface. Yeah, you found it. That was the cloud provider types. That's kind of one area to think about how would that work for CAPI. And then the other one is like, how do we model these like CRUD for node claims? And then the really interesting one I think is get instance types. How do you model that with CAPI?
Yeah. And this was, previously I had put a lot of thought into like how we would do get instance types. And I think that this is going to depend at some level. I think this is going to depend on how tightly coupled like things like machine pools are into this implementation, because machine pools are going to look more like, they're going to have a whole bunch of instance types they could give back. But we also have the notion of like machine deployments, which represent a single instance type. So like theoretically, those could be enumerated and sent back as well. So I think we'll probably have to do some work on the cluster API side, maybe to surface some of this information. But I think it's possible. Cameron, you've got your hand up. Please go ahead.
Yeah, I mean, I was gonna ask some of the same questions that you were just raising. Like, I'm really interested to know how a peer provider is gonna integrate with like the cluster API types and CRDs, because a lot of the assumptions that Carpenter makes sort of don't really mesh with the model for machine deployments at all. But then there's a different question: is like, well, does the resources that Carpenter uses look like machine pools? And maybe they do, maybe they don't, but I feel like, that's also something we need to figure out and determine.
Yeah, absolutely. I'd be curious to hear more about about the specific parts that you're thinking about that don't mesh well between like the CAPI objects and the expectations of the Carpenter API.
So like machine deployments have a strict contract that they can only be tied to one instance type. So that's just going to be right out.
So like in the past, the way I had thought about this though was right, like if we have the provider interface to core Carpenter is like our abstraction point. If behind that abstraction point, we can enumerate the machine deployments that have made themselves available for like auto scaling behavior, then like my original thought was we could enumerate those machine deployments to learn about their machine types and then provide those back as like part of, what the provider could do when it's requested to create a specific instance type.
Yeah, I could see something like that working, but it seems like we would need some sort of higher type to wrap all that up then, because then machine deployments would be some lower construct underneath of it.
Yeah, I don't like. I'm just proposing this as like, and actually, Ellis, I see your hand up. Why don't you go ahead?
Yeah, I was going to suggest scrolling down to instance type just to like be really clear on what that was. Like in our sense, it's like it's an option of a shape of a node that can exist in the cluster. And I think what you were saying is like that's kind of what machine deployment is. It's just an option of the shape of a node and a replica count. And so it's like a little bit of a mismatch. Maybe there's like a common abstraction there that could be pulled out. Um, I was just going to suggest scroll down here in this file to the instance type struct. Um, so just for those who aren't familiar, requirements is things like it's essentially think of it as like a node selector, but it's the node labels essentially. It's more complicated than node labels because you can have multiple values. So we model it using a set essentially. It's like these are the possible values it could have. For example, like spot and on demand for the capacity type, those are two options that the instance type can have, or Linux or Windows are two options that this instance type can have. Um, the other thing I think that I'm kind of curious about as a fundamental assumption that we're making is that we're thinking very much around how do we integrate Kubernetes CRDs together as our integration point, and we're not thinking about other integration models. Like another model could be we define a Go interface, and that Go interface defines, what does it take to bring up a node claim or a machine or a single to do the launch on a provider, and maybe that's kind of a more natural atomic unit of abstraction that we could think about kind of building up from. You could imagine a library approach that both CAPI and Karpenter uses. So you're not necessarily integrating with the CAPI API, but you could be integrating with the libraries. And then maybe you could have like a library that supports like all of them at once or something.
Yeah, no, absolutely, Ellis. And that's kind of the direction I've been investigating. Cause yeah, I think trying to conflate these CRDs is just, there needs to be something in the middle that handles that transaction, some sort of mediator. And that, in my mind, that's always what I thought the CAPI provider would be in the Karpenter parlance. Is it would be that mediator between the objects that Karpenter wants to speak about and then the objects that CAPI wants to speak about. So yeah, I like
the other thing I'd note on the point around like abstraction and interfaces is every time you build an abstraction, it has like a contract. And the more of those contracts you have, like if you don't get them perfect, you start to lose things. And that was, I think, the whole point of why we built Karpenter in the first place was that the contract between CAS and ASG in the case of AWS or CAS and a node pool, that contract had an assumption around uh, uh, essentially every node group has to be completely different, and the combinatorics of that grew in a way that didn't work for our customers. So we essentially had to remove that abstraction layer, which is roughly how we got to where we are with Karpenter, where you have all this flexibility built into the node pools. I would be super cautious about any sort of integration that is trying to hook up that interface to that interface in a way that's not totally natural. Because when you do that, you add a bunch of failure modes, you add a bunch of latency, you add a bunch of complexity. And I think that like that's always the trade-off of trying to, of course, we want to achieve like portability at the end of the day. But I guess that's the other side of the coin.
Yeah, those are great points. Thanks for bringing them up. Pao, you've got your hand up, please.
Yeah, I just want to talk about a little bit how we at Transform envision this and how we are using Karpenter right now in CAPI. And basically what we're doing is we're creating a node pool on the CAPI side, and then on the workload cluster, we're deploying. Up until now, we used provisioners. Now we need to do the node classes and node pools, right? Basically taking over the resources that the CAPI node pool actually created, right? How I would like it to see this is that the CAPI actually creates this node pool and node classes on the workload cluster directly, right? So it creates all the infrastructure that the workload cluster needs to boot nodes, and then it can create the node pools and the node clusters and the node classes, yes, to let Carpenter create the nodes from inside the workload cluster itself.
And then do you reconcile the cluster API objects back from that, or do you just not create like machine objects to go with those new nodes that are created?
So for now, we're not doing that. That would be, let's say, a nice to have for us, but currently we are not representing those machines back into the CAPI world, which I think would be much better, right? To actually have the full circle representation of what's actually inside the cluster. We're not using that right now, but it's would say that's a later stage that would be nice to have.
Yeah, I think this is like one of the tough things. I think there was another feature group in the cluster API community about managed Kubernetes. I think this is one of the toughest things we face, right? Is that and also I think this also speaks to something that Ellis was just talking about in terms of the abstraction layers, right? Like it would be nice to have a generic cluster API provider for this, because then theoretically you could use it with any cluster API provider. But then you sacrifice the expressiveness of the abstraction between what Karpenter is kind of expecting and what we provide through the cluster API interface. And does that mean that we're losing some performance or some kind of capabilities in the cloud because of that? And then also, if you go that direction, you say, well, I'd like to have a provider specific Karpenter, then is it all right to sacrifice on not having those cluster API objects in the system? Is that something that users are okay with? And I think this speaks exactly to one of the points around what users want out of this integration. Would a cluster API user be ready to integrate Karpenter if it meant that they didn't get updates to the cluster API CRDs are in the system? Or are users kind of expecting those APIs to be there, and so they need a Karpenter that can update those APIs? And I think that's probably one of the most difficult questions that we have to face as a community. So I appreciate your input there, though, Pal.
Mm-hmm.
And also to add on to that, like what are the consequences of not doing that work? And like the CLI tools, will cluster CTL move not work if you don't implement that?
Yeah, that's a good question. So I mean, like some of these things are questions that we as a cluster API community need to kind of come up with as well, right? Like when we talk about having Karpenter as something that you can use with cluster API clusters, is our community expecting that means that you'll have cluster API objects to represent everything that's happening in your cluster? And I'm not sure how we would answer that, or like, is that something we need to take to the wider community and have like a survey or something? Or is that a meaningful question to answer even? Like, I mean, I think it is, but
I don't know. I've never been part of one of these feature groups before. Like, how do we typically gather the requirements that we want? Because that's what we're trying to do, right? Gather the requirements.
right. Well, that's, I don't think there's like hard guidance about how we do that, but this is, as a community, this is where we'd probably, if we want to, figure this out, we'll need to do some outreach. Ellis, please, you raise your hand.
Yeah, I was just gonna say, like the model of Carpenter so far has been like very, very driven by customers. Like it's super hard to guess about. Like we like often when we end up like, how are customers actually using this? You kind of have to go. You have to have like your bag of customers, that your go-to references that you trust to kind of know the ins and outs of an average use case. Does CAPI have like those landmark customers that are deeply involved in the? I know there are some folks here who are like from Adobe or whatever, but maybe that's the answer. But yeah, like what are the? Do we as like a CAPI community have that cohort of kind of dedicated users who would be representative of the overall community?
I mean, it's a good question. I don't think we have like a pipeline set up to make that communication easy, but we do have a lot of like, we do have a lot of end users who also participate in the community meetings, kind of representing the organizations that they're in. And, maybe that's kind of the next step here, is just take it to a wider community meeting to ask for more input. Pao, you've got your hand up, please.
Yeah, I kind of forgot what I wanted to say. And just on this last thing that we were talking about, we as a service provider, we have been introducing Carpenter to our customers. So I would say, not a huge amount, but I would say a handful of customers where in each of them we have Carpenter, and I could provide some feedback also on how we do this. We are currently not in Capi yet, but we're gonna move to Capi, and we are moving with Carpenter to Capi. So we will have to do it one way or the other way. We'll have to.
Okay, so like it sounds like from your perspective, then like you're going to have to figure out how to reconcile these like cluster API objects eventually, whether that means writing some extra controller to do it or having some sort of integration in Carpenter. Like you're going to need to have that done eventually.
Yeah. And now I remember what I wanted to say before, because I'm also working right now on the cluster autoscaler, and I want to check how it's done there, right? Because I think it's similar in a sense, right? Because I want to check what happens when the autoscaler decides to scale up, right? My guess is that somehow something will create a machine to represent the machine that came out from cluster autoscaler, right? So I would say that Carpenter should kind of work the same way. Whenever Carpenter boots a new machine, this controller should have the same representation as a machine on Capi, right? That's, let's say, the way back, not how you define the node classes and the node pools, but I would say definitely long term, we should represent the machines the same way as cluster autoscaler does.
Yeah, so that's the difficult part, right? Cluster autoscaler, CAS, like it speaks purely cluster API. So it knows about machine deployments and it knows about machine sets, and it just increases and decreases replica counts there when it wants to do scaling. So it completely relies on the cluster API mechanisms to do that scaling work for it. Now, it doesn't support machine pools right now, so you can't get that type of behavior. So that that kind of informs my bias as how I've been coming to this, because I do a lot of work on the cluster autoscaler as well. And I'm approaching it from that perspective. Like if we could get Carpenter to speak purely to the cluster API objects, then yeah, maybe we'd have this kind of way to just make it work generically for all cluster API.
But is that still the case when cluster autoscaler runs from inside the workload cluster? Because then cluster autoscaler doesn't speak Capi, right?
Well, it depends. Like, so if you set up the cluster autoscaler to run in the workload cluster and you set it up to use to not use cluster API, but to use the underlying provider, then yeah, it'll make nodes and there'll be no cluster API objects to go with it.
Okay.
But you can configure the cluster autoscaler so that it lives in the workload cluster, but has a kube config pointing back to the management cluster so that it could actually modify the machine item. So if you're doing like a hub spoke kind of deployment for cluster API, you could deploy the autoscaler in the workload cluster, but have it adjusting things on the management cluster if you wanted to. So there's actually two ways you could run it like that.
Okay.
I
So
want to
there is no
caution.
discovery. Oh, sorry.
I want to add a caution. Like, I don't want us to look too closely at the cluster autoscaler implementation. There are some architectural flaws with how it integrates with cluster API specifically that can't be reconciled. The cluster autoscaler can't operate correctly when there are multiple machine sets and a machine deployment. This is just unreconcilable due to the architecture decisions that were made a long time ago. So like we should make sure that we don't repeat any of the bad patterns in the cluster autoscaler.
Yeah, +1. All right. So I mean, it sounds like at some level we've got more research to do here to kind of figure out. Like, I know I need to do more research to understand a little better, the interface points between Carpenter and Cluster API. But I guess, like, could we agree as a group to start investigating that direction to see if we think that that's maybe the way we want to go? Ellis, please.
I wanted to question another assumption, which is that Carpenter sits on top of Capi. in that like Karpenter is like we have our node claim abstraction, which if you're familiar with PVC or other types of claims in Kubernetes, it's a request for a node essentially. It maps to an EC2 instance or a GCE VM. Cappy has machine essentially for the same concept. And we're thinking about how do we put Karpenter's node claim on top of machine, I think. Like for these, the description of the use case of like, oh, if customers want to reason in terms of Cappy objects. I think similarly, like node claim is a generic API. It's not AWS specific. It's Karpenter's primitive of what a VM is. And similarly, like our node pool resource is also kind of a primitive of a collection. Another model for this would be to invert and to say, like, say, for example, we have a Karpenter provider for 10 different clouds that all implement node claim. You could build a machine deployment or even machine out of that node claim as well. Like you can go both directions essentially. Like because we both have this foundational primitive and then we split off in different ways for how to orchestrate that primitive. Cappy went the route of kind of more the classical cluster autoscaler machine group deployment, thinking about groups of things, groups of homogeneous things, and Karpenter went thinking about groups of heterogeneous things. It's not clear to me like that either one necessarily deserves to be like at the bottom layer necessarily. Like for example, you could build, and this is kind of crazy, but you could build a Kubernetes control plane out of Karpenter node claims. You just set the machine image to be whatever AMI you want for your kubelet and have them all talk to each other and bootstrap a control plane out of that, right? And similarly, you could also, like I guess like by the time you have these like the right primitives, you can kind of build more complex things out of them. And I do wonder like if we kind of have this irreconcilable state with the current API. I think machine deployment is super valuable. Like it's our top upvoted issue in Karpenter right now is being able to statically provision these node claims. It's like one of our biggest customer requests. And I think we're going to need to build something like that. But I guess like the core primitive is where we have just like a straight duplication of effort essentially. And it makes sense why we have that, but yeah, I don't know. I think that's the other piece of the question is like, do we try to stack these, which is on top of the other, or do we try to merge them in some way, or pick a winner? I mean, that's a very hard thing to do. Like, I think we are in a place where node claim is not going away for AWS, so it's kind of a difficult conversation, I guess. But and I'm sure you guys are the same for machine is not going away for Cappy,
Right.
But yeah, I don't know. I think that's kind of where some of the root of the complexity is.
Yeah. So like first, I'd say please excuse my rough language a little bit. Like when I'm talking about the layer cake, I look at it with Cluster API at the bottom because I'm viewing those providers as doing the actual like cloud calls or whatever, that are making whatever's going to happen. So in my mind, that's kind of why I visualize it that way. But I think what you're saying makes a lot of sense. And it probably also brings into the notion of like, would there ever be a way for like maybe Cluster API providers could also understand node claims and then could respond to that in some way? Like you're saying, maybe there's some way to mix the peanut butter and the chocolate in a way that makes it, palatable. I think that's worthwhile to investigation to have. Like so far, what I've been looking at it from the perspective of if Karpenter generates a node claim, how could we have Cluster API kind of react to that node claim and fulfill it, So I've been looking at it from that direction. But yeah, maybe there's a way for the Cluster API controllers to know more about node claims, and there's some way to combine it even tighter. So like I think that's a great point. Thank you.
From an API compatibility perspective, if we decide these APIs cannot go anywhere, kind of the next logical conclusion is you would align at the Go interface layer. So you could share a Go implementation that has a shim to each API, and that's kind of your primitive.
Right. And this may be, if we end up with like some sort of Karpenter cluster API, it might look like that where we ask the providers to like expose a module that's their node claim interface or whatever. And then when we build the Karpenter Cappy, we pull in those modules from the various providers, and then we know that, okay, if this thing detects it's on one of the clusters that has support for that, then it can operate, efficiently. And maybe that's where we end up. And then that gives the individual providers a great opportunity to get involved in this and kind of like make their provider, kind of work better with Karpenter or whatever. So yeah, that's great. We got just a couple minutes here left. Are there any other topics people want to bring up or things we should cover before we call it to a close for this session? All right, I'm not seeing any hands go up. So our next meeting will be in 2 weeks. And if anybody wants a Google Calendar invite, please give me your email address and I'll add it to the calendar invite I've been having going. It's kind of ad hoc, apologies. There's not a better way for us to do this. But I will upload this. I will upload this to the Cluster API list, and it should be, hopefully online sometime later today. All right. Thanks everybody for showing up.
Thanks, Mike.
Thank you.
Yep.
Bye-bye.